Hello everyone, so welcome to another video on Arduino tutorial. So in today's video I'm going to show how we can use analogWrite function. So far in the series we have seen how we could use the digital write to power an RGB LED, and we have also seen how to use the digital read input to read the state of the push button and then use that value to control the RGB LED. So in today's video, we are going to use a different method which is analogWrite. So what we are going to do is we are going to use the analogWrite function to control our LED, and by control I mean we are going to dim our LED from off state and then gradually increase the brightness to the highest level possible. Alright, so we are going to start with a blank sketch, or the default sketch that we get when we open a new sketch on the Arduino. So I have set up my circuit. As you can see, I've taken a red LED this time, and I've connected a positive terminal of the LED to the D9 pin. Alright, why D9 pin? Because it is a PWM pin, which is pulse width modulated pin. So this allows us to modulate the waveform to control the power that is being supplied to the LED. In place of D9, you could use any of the pin that supports PWM, which in our case for the Arduino Nano, we have D9, we have D10, we have D11, D6, D5 and D3. All these pins are PWM pins, and we could use any of these pins. So I'm using D9 pin. Alright, so let's make the connection for the circuit. So I'm taking a red LED and my positive pin is on the left hand side, and I'm going to connect the yellow wire to the positive pin of the LED, and the green wire is connected to the negative of the LED. So the positive of the LED will go to the D9 pin, and that pin is a PWM pin. Alright, so let's make the connection. Yellow goes to the D9 pin, and the green one will go to the ground pin of the Arduino. Alright, so let's make that connection also. So this is it for the circuit. So first thing that we need to do is we need to create the constant to define our pins. So I'm going to declare it const int. Alright, since we are using D9, so I'm going to use it use a value 9 for the pin value. Alright, next thing we need to do is we need to set up the LED pin to be an output pin. Alright, for that we are going to use the pin mode function. So this line says that this is our output pin. Alright, so in the loop function what we want to do is we want to start with a 0 value for the LED and then gradually increase it to the highest value, which is 255. Alright, so let me start with it. So for that, in this tutorial I'm going to use a for loop for that purpose. Alright, so let me define a initial value, or the loop variable we also say Usually I'm just going to use a name as loop variable, and I'm going to start it with 0, or I can even like just leave it as it is, so that I'm going to initialize it inside the for loop. So you must have seen this for loop in other programming languages also. So this is the initialization part, this is the condition part of the loop, and this is the incrementation or the increment part of the loop. So here we are initializing, and this runs only once before the loop starts. This is the condition that is checked before the body of the loop runs, and this is checked each time or in the each iteration of the loop, and this happens after each iteration when the body of the loop executes. Alright, so we are starting from 0 and we are going up to 255, and we are incrementing the loop variable by 1 after each of the iteration. What we want to do is we want to write on the digital pin using an analog value. So we are going to use analogWrite, and where do we want to write it? We want to write it on LED pin. And what is the value that we want to write? The value is the current value of the loop variable. Alright, this is what we want to write on our LED, and after each value we want to provide some delay, and this delay will be of 100 milliseconds. Alright, so when this loop completes, the value or the output intensity of the LED will be at highest. Now what we want to do is I want to gradually decrease it to 0 before restarting the iteration again. So I'll provide a delay of around 500 milliseconds after the loop completes, and then I'm going to use this for loop in reverse. What I mean by that is, so instead of initializing it, I'm going to leave it as it is. So I'm going to leave this field here blank. So we already have a value in our loop variable, so which is 255, because when the variable value reaches 255, this loop or this for loop will break and it will exit the loop. Alright, so current value is 255, and this time we don't want to go up to 255, we want to go up to 0, and we want to make sure that it is greater than and equal to 0. Alright, and instead of increasing the loop variable, we are going to decrease it this time. Again it will have some delay, and we are again going to provide one more delay of 500 milliseconds. Alright, so let's quickly summarize what we have done is, so we have chosen the LED pin 9 as our output pin, and we have used the pin mode inside the setup function to make it an output pin. Alright, inside our loop function, what we have done is we have defined a variable named loop variable that will be used to control our loops. So we have used a for loop that goes from 0 to 255 incrementally or gradually, and in each iteration of the loop we are writing the current value of loop variable to the LED pin, which is the output pin, and we are using the analogWrite function. Then we are providing a delay of 100 milliseconds between each iteration of this for loop. So once the value reaches 255, it will break the loop and it will reach this code, and then again we are using another for loop, and but this time what we are doing, we are using a higher value and gradually decreasing it to 0. And again there is a delay of 500 milliseconds after the for loop, and since this loop runs simultaneously inside our code, so it will again initialize the loop variable back, or it will again define it to some value, and this will be initialized to 0 in our for loop. All right, so let's save this sketch. So let's connect the Arduino. So I have connected my Arduino to my system, and let's try to upload the sketch. So it is saying that it is still uploading, and it is done uploading. So as you can see that the LED is gradually powering on, and it is going up to a high value. So this is it. As you can see, it is gradually increasing from a low value to a high value, and then after some time it is getting down from that high value to a lower value. All right, so now what I want to do is I want to make some more changes to this code. All right, so this code or this loop is like, it is linear, so I don't want a linear behavior. So this time I want some random behavior. So for that, let us try something different. All right, so instead of using this code right here, so I'm going to comment this whole code, and so what I'm going to do is I'm going to use analogWrite, and I'm going to say that I'm going to use it on LED pin, and this time I want to use a random function. All right, so what is this random function? This random function generates a random value. All right, so let's say we want to generate a value between 0 and 255. So if I say 255, this random function will generate a value from 0 to 254. So whatever value we pass it here, it generates one less value. So if I pass 256, so it will generate any number between 0 and 255. All right, so I'm not going to use this loop variable also, so I just want to use this analogWrite. Then I'm going to use a random value, and instead of using this 500, I'm going to use 100 milliseconds delay. Alright, let's save this and use Control plus S, and let's try to upload it this time, and let's see what happens. So as you can see that the LED is still, it is still controlled, but it is not going from a low value to a high value. It is flickering in a random behavior. So, or you can say this random behavior is similar to an artificial candle. So let me quickly switch off my lights and show this random behavior. So this is something similar to an artificial candle, or the behavior of the candle, and this is flickering. So in my future videos I'm going to create the artificial candle also, and I'm going to use some white or sun white lights to create something similar to that. Alright, thank you guys. So this is it for this video. Do like my videos and make sure to subscribe the channel if make sure to subscribe the channel for more amazing videos like this. And I'm definitely going to continue on this tutorial series, and I'm also going to post a few more projects on Arduino, so that will be something apart from my tutorial series. So that's it. Thank you guys.